Okay, so this is going to be a video that gives the basic groundwork for algebra. Now I'm going to go really broad and I'm just going to say algebra is basically any problem that you're solving that involves a variable. Okay, let's just make it that simple. And let me show you what I mean by that. Suppose I give you the problem x minus 5 equals, oh, I don't care, let's say 3. And I say, what is the value of x in that equation? Well, you look and you think, okay, what number, if I subtract 5, do I get 3? Oh, x must equal 8, because 8 minus 5 is 3. Exactly. Suppose I said x plus 7 equals 10. What number plus 7 equals 10? X equals 3, right? Because 3 plus 7 is 10. What if I gave you the problem 3x equals 12? 3 times x equals 12. Well, what number times 3 equals 12? X equals 4. So you look in this, I used x each time, but it had a different value in each equation, 8, 3, and 4. The value for x varied. That is why it's called a variable. So when you see a problem and they talk about the variable, you don't need to be scared of that. All it means is I've got something, usually a letter, taking the place of a number, because the number varies and we don't know what it is. A variable is an unknown. Sometimes you'll also see that written. Okay, and you're like solving for the unknown number. All right, so these are two important terms to get when you are solving these. But whenever it says what is the value of the variable, that's all it means. It's nothing scary. It just is called a variable because it varies from equation to equation. So take a look at these three. Those were easy to solve on their own, right? We could reason our way out. But there are steps that will help us with solving for algebra problems. Here's one of the first things you really need to understand with an algebra equation. An equation, it's like a scale. Both sides are equal, okay? They're of equal value, which means, let's say this, anything I do to one side, I have to do the other. If this is a scale here, and I take some off of this, well, if I want them to be equal, then I have to take the same amount off of this. If I double that, then I have to double that, because a scale, it's like a teeter-totter, right? It's got to be completely equal. So suppose I had this, I'm not going to make it fancy, all right? But let's just say this is my scale, okay? These two things are perfectly balanced. They are equal. They are an equation. And this side had 7 circles on it, okay? 2, 3, 4, 5. Well, that side needs to have 7 circles on it for them to be equal, which I know you're not that concerned about it, but I am. Let's make it, well, is that better? Because I want it to be flat, okay? So they're perfectly equal, right? Well, what happens if I add 2 more here? Then I have to add 2 more here for it to stay equal. What if I subtracted 4 from here? Then I have to subtract 4 from here. Okay, so that leads us to a key algebra principle, and that is that anything you do to one side of the equation, you must do to the other. You can't just randomly subtract 5 from one side without subtracting 5 from the other side. Or I can't just multiply this side by 7 without multiplying this side by 7. That's super important. It's going to come up again and again and again. Now, let me show you the 3 key rules in solving an algebra problem. The first one is that you are going to solve both sides of the equation. You're going to do whatever you can to get that side solved completely, and I'll show you what that means in a second. Specifically, this is going to involve combining like terms. Again, I'll explain in a second. The second step is going to be that you're going to isolate your variable term, which means get it by itself. Okay? And then your third step is going to be that you're going to solve for the variable by doing the opposite operation. Now don't panic when I say that. If I said multiplication and I said, what's the opposite of multiplying? It's dividing, right? What's the opposite of adding? Subtracting. The one that's a little trickier to remember is the opposite of an exponent is a square root. Okay, or not square root, is a root. The opposite of exponent is a root. We'll get to that more later. But that's all I mean. So almost always. And so I'm going to go and write this. The third step is usually going to be dividing. And I'll, again, explain that in a minute. It won't always be that. If there's an exponent, it won't be this. But it's normally going to be, the last step is normally going to be dividing. Now let me show you how this even works with these really simple problems, because I want you to see when you figure out these rules and you understand them, you can solve everything. Really hard problems, really simple problems. They all follow these rules. So let's look at this. X minus 5 equals 3. Solve both sides of the equation. Well, x minus 5, I can't do anything more with that, right? Those aren't alike. 3, it's already by itself. So that one's already done. Second step, isolate your variable term, meaning get it by itself. Well, I want it by itself on this side of the equation. What's my problem? This minus 5. So I need to move it to the other side so that I can isolate my variable. So I'm going to do the opposite to this. This is minus 5. So I'm going to add 5. Oh, but remember, anything you do to one side, you have to do the other. So if I add 5 to that side, I've got to add 5 to this side. So I still have my x, okay? Minus 5 plus 5 is 0. That's what I wanted to do. I want this to be 0, so I don't need it anymore. And what is 3 plus 5? 8. You see how that solves? Let me break this up a little bit better. So you can see, whoops, that's not a very good marker. Just trying to use a different color. So it solved to that. Obviously, we could reason this one out without these steps, but again, these steps always work. So let's look at the second one then. Let's think this through. Right here, x plus 7 equals 10. Solve both sides. Well, I can't do any better than that, can I? X plus 7 doesn't solve, 10 is by itself. Isolate your variable term. I want my x by itself. So this 7 needs to be moved to the other side. So I'm going to subtract it. Anything I do to one side, I must do the other. So now I have x . 7 minus 7 is 0. That's what I wanted. Equals, what is 10 minus 7? 3, which I'd already gotten to, right? Then the third one. Let's look at this. 3x equals 12. Solve both sides. Well, there's nothing else I can do. Isolate your variable term. Well, it's done. My 3x is by itself on a side, right? So I'm to the next step. Solve by doing the opposite, which I said is usually dividing. We know that this 3x means 3 times x. The opposite of multiplying is dividing. So I'm going to divide this side by 3. Anything you do to one side, you must do the other. I chose 3 because what is 3 divided by 3? It's 1. And remember, we don't have to write that in front of the x. It's understood that that's just 1x. And then what is 12 divided by 3? 4, which is what we already knew by reasoning it out. So you can see that these steps always work. It doesn't matter how complicated the problem is. These are going to be the steps you go through. Even when I can reason it out, it still followed those 3 steps. So we're going to get more challenging here. We always follow those 3 steps, and we always apply that rule. Okay? So I'm going to erase these things. Let me actually. I'm going to write that again, and I'm going to take a picture of this. Because I might put this on there too, so that you can look at this on your own. But you can certainly do a screenshot of this as well. Sorry, I'm going to get a better angle here. Apologize. Get out of the glare. Okay, so I may post that on detail as well. This is our understanding though. Let me make one more note with this. I used X. I literally could have put a star here. Okay, that would just, or a Christmas tree, but that'd get kind of crazy if I'm going to go, I mean, it'd be a little ridiculous if I'm going to go in and draw that. But the point is, a variable is something unknown, and it's a symbol that's standing for in the place of this unknown quantity. What you'll see, sometimes they'll use the letter N for number, but it doesn't matter what it stands for. You could use T, you could use S, you could use whatever you wanted. If I was solving a problem that said, you know, Johnny has 20 dimes and nickels, and they gave me how much it was worth, and they said how many are dimes and how many are nickels, that's a more involved problem. But if I were solving that, I would use D for my number of dimes and N for my number of nickels. It doesn't matter what you use. I'm just going to pick a variable. I'm going to pick something to stand for my unknown quantity. All right? So X is not magic. It's what we use the most often. But I can use other letters for variables and solve for them. Okay, so let's take a look at a problem then. Stay with the black. I think it shows up better. That goes through more of these steps. Let's suppose I had, I choose 3. Let's pick something different here. Let's go with 4x minus 7 equals 9. Okay, 4x minus 7 equals 9. Let's go through our steps. Solve both sides, which is combining like terms. 4x and 7 are not like terms, so I can't combine them. So that stays alone. 9, of course, is nothing to do with that. Next thing, isolate your variable term. 4x is my variable term, right? It's got the variable in it, so this whole thing represents one particular quantity. We don't know what it is yet, but I want this isolated by itself. So the 7, this minus 7 is what's got to move, all right? So I'm going to do it. If I add 7 to that side, then my negative 7 plus 7 gives me 0. That's what I want. Anything you do to one side, you must do the other. So I'm going to add that. So I have 4x equals 16. Okay? So now my variable is by itself, my variable term. So I'm going to, third step, solve by doing the opposite. Well, this is 4 times x. The opposite of multiplying is dividing. So I'm going to divide by 4. I divide that side by 4, divide this side by 4. I chose 4 because 4 divided by 4 is 1. And the name of the game is I want 1x. or if I was solving for n, I want one n, I want one t, whatever I'm solving for, I want one of them, because I want the value of one of them. So this is what I wanted. That, you know, gets me down to 1. And what is 16 divided by 4? It's 4. You can always use your calculator on these things, certainly to check it, especially make sure you didn't make a math error. It's 4. But I'm going to show you how to check this now if I wanted to go back in on doing this. I'm telling you that I believe that in this equation here, x has a value of 4. So let's see if that's true. I'm going to rewrite it down here. I'm not making any changes to it. I'm just rewriting it. Okay, I rewrote this right down here because we're going to check it. And I'm saying that x equals 4. If I didn't make a mistake, x equals 4. That means that every time I see x, I'm going to put in a value of 4. So let's check that out. 4 times 4 minus 7 equals 9. What is 4 times 4? 16 minus 7 equals 9. What is 16 minus 7? 9. Does 9 equal 9? Yes. So this one checks out. Okay, that checks as correct. That's how I could always check my answers, is I can go back and plug them in. Okay, you see that okay? All right, so let's look at another one. Let's say I have 5x plus 8 equals, let's go with 28, okay? So, first step, solve both sides of the equation by combining like terms. Well, 5x and 8, I can't combine them any further. Next step, isolate my variable term. So I want my 5x to be by itself. This 8's what's got to move. So, I'm going to subtract it. If I do it to one side, I must do it to the other. So now I have 5x. 8 minus 8 is 0. That's what I was going for. 28 minus 8 is 20. Okay, so that's done. Third step, solve by doing the opposite. This is 5 times x. The opposite of multiply is divide. Divide by 5. If I do that to that side, must do it to the other. 5 divided by 5 is 1. So I get x equals 4. All right? So let's see if that checks out. I'm just rewriting the equation. And I know on the high set, you're not going to necessarily have time to check everything. I just want you to see how these work and why they work, okay? So I'm saying that this is 4. So let's see. 5 times 4 plus 8 equals 28. What is 5 times 4? 20 plus 8 equals 28. 20 plus 8, 28 equals 28? Yes, they check. So in this equation here, x has a value of 4. Now let me go over something that I've said here a couple times and make sure we're clear on it. When I talk about combining like terms, that literally means you can only combine, I can only add and subtract terms that are alike, meaning I can add all my x's to x's. If I had y's, I can only add i's to y's. I can add my numbers to my numbers. So let's suppose, let me show you first this example. If I had 5x minus 3x, what is 5x minus 3x? Well, they're both the same thing. They're both x terms, so they're like terms. So I just deal with the number in front of it. That's called the numerical coefficient. You'll use the word coefficient in science too. So it's nice to know what that means. 5x minus 3x is 2x. Let's suppose I had 7, let's call them n. 7n plus 4n minus 6n. Well, 7n plus 4n gives me 11n minus 6n. 11 minus 5, I'm sorry, 11 minus 6 would give me 5n. combining like terms. Let's suppose I had 9x plus 6x minus 5 plus 2. And they want me to write this in simplest form. I can only combine like terms. So my 9x plus my 6x combined, 9 plus 6, that would give me 15x. Minus 5 plus 2 gives me minus 3. And you'll have your calculator, you can check that. But negative 5 plus 2 is negative 3. But you notice I can only combine the terms that are exactly alike. Okay? Let's suppose I had, they're not, I put those in order. Let's not put it in order. Let's suppose I have 10x plus 7 minus 8x minus 5. Okay? Well, I got to find all my x's first. 10x minus 8x. 10 minus 8 is 2x. 7 minus 5. What's 7 minus 5? Plus 2. Are you following that? I'll make a worksheet that has more combining like terms problems on it so we can really work on those and we can make sure you've got that straight. What if I had two different variables in there? Let's say I have 8x plus 12n minus 4n plus 6. I'm going to get really fancy here, guys. Minus, because I know we can handle it. Whoops. Minus 5x. Combine like terms. You got to find them. You notice I always put a different kind of squiggle or mark underneath each one so I keep track of it. I want to keep track that I've worked with it. I don't want to cross it out. I don't recommend that because then when you go back to check it, you're like, I can't tell what I wrote because I've scratched it out. So let's see, 8x minus 5x. 8 minus 5 is 3x. 12n minus 4n is 8n. And 6 is all by its little lonesome there. 6. You see the pattern? So that's what I mean when I say combining like terms. Let's get one more wild one here. 7x plus 3y minus 9 minus 10x minus 14y plus 12. Got to find all my like terms. Let's gather them up. 7x minus 10x. 7 minus 10. Give me negative 3x. Again, you can use your calculator. Just do 7 minus 10, but don't forget my x because it has value. We just don't know what the value is yet. So I've got negative, see the negative there, negative 3x. I've got 3y minus 14y. Again, 3 minus 14 will give me minus 11y. And let's find my constants. Negative 9 plus 12 plus 3. So this is my final answer. And you might see a problem. This, literally, just this problem might show up on the high set. It would say simplify. And that's what it means. You're combining like terms. So that's the first step. All right, so let me show you an algebra problem that might involve you doing that. Okay, so let's suppose I have 4x plus 2x equals 24. Okay, first I solve both sides. So I do whatever I can to get it as simple as I can. Combine like terms. Hey, I have 4x plus 2x. Well, I can do that. That's 6x equals 24. All right, that's solved down. Second step, isolate your variable term. It's already done. It's by itself. Third step, do the opposite. 6 times x. So I'm going to divide, because I'm doing the opposite. Divide both sides. That gives me x equals 4. I can check that. I'm just going to write it up here. This would be 4 times 4, which is 16. This would be 2 times 4, which is 8. Does 16 plus 8 equal 24? Yes. So this is my answer right here. Okay, let's look at another one. Let's say I have 3x plus 5x minus 10 equals 26. Okay, first step, solve both sides. Hey, I have some like terms. 3x plus 5x. 8x minus 10 equals 26. That's as good as I can do. I can't combine any further, right? So now step 2, isolate your variable term. So I want my 8x by itself. What's got to move? This is got to, oh, you know what? I didn't mean, let's not do that. Let's go, let's do 32. 22, I'm sorry. I'm thinking ahead. Let's go 22. So let's see. What I got to do, I need to move the 10. So my 8x stays. Negative 10 plus 10 is 0. That's what I wanted. 22 plus 10 is 32. Isolated. So third step, solve by doing the opposite. And divide by 8. Divide by 8. X equals 4. Because 4 times 8 is 32. The only reason I changed that is I was trying to get a whole number as an answer. If I got a fraction, that would be fine. I'm just not trying to teach with that right now. So x equals 4, huh? I'm on a roll, right, with x. Or with 4, okay? So let me show you one. What I haven't done so far is throw a negative number in there. So let's do that. Let's say 3x plus 2x minus 20 equals, let's do that. Let's say negative 40. Let's just start with that negative right out there, okay? It's not going to change anything. It's just going to mean I got to pay a little more attention. First step, solve both sides. 3x plus 2x. So I have 5x minus 20 equals negative 40. All I've done is combine like terms, step 1. Can't do anything more. So now I want to isolate my variable term. It means I want my 5x by itself. Well, this is what's got to move. So I'm going to add 20. Do it to one side, must do it to the other. 5x, negative 20 plus 20 is 0. That's what I wanted. Negative 40 plus 20, again, use your calculator, but I can tell you that is negative 20. Okay? Third step, solve by doing the opposite. We're going to divide by 5. If I divide by 5 is 1. X equals negative 20 divided by 5. A negative divided by a positive is a negative. So my answer is negative 4. And I can tell you on the test, positive 4 will be one of the choices. So you got to pay attention. The answer, though, is negative 4. You following that? And if I plug that back in, it would all work. I can see it right here. This would be negative 12 minus 8 minus 20, and that would be negative 40. You can check it on your own. You can pause the video and check that if you want. But don't lose that negative. Super important. It changes the value. You know, this is what I always say when if you're thinking through, well, is that really that big a deal? If you get your bank account, your bank statement, and it says you have positive $20, so just say $20, we'll put the positive sign. It says you have $20, or it says you have negative $20. Is there a difference? Yes. Big difference, right? Those are not the same number, are they, at all? It's a difference of 40, literally, from positive 20 to negative 20. So you cannot lose that negative number, and you can't, that negative sign. You can't just say, well, I mean, I got 4, or I got 20, or whatever. It's not right, okay? It's the wrong number. So yay, because you did most everything right, but, oh, can't drop that negative. Math is about details. Let's try another one like this. Let's say 2n minus 6n plus 5 equals 21. Okay, first step, solve both sides by combining like terms. 2n minus 6n, that's going to give me negative 4n plus 5 equals 21. So I've done everything I can. I've combined like terms. Second one, isolate your variable terms. So I want my negative 4 in by itself. So my 5 is what's got to move. All right, so we're down now. Negative 4n equals 5 minus 5 is 0. That's what I wanted. 21 minus 5 is 16. So this is the third step. Solve by doing the opposite. So I'm dividing by negative 4. Now here's why. Because remember, a negative divided by a negative is a positive. And I don't want to end up with my value of negative n. I want n. They're going to say, what is the value of n? So negative divided by negative, that's going to be positive 1. 16 divided by, well, I'm on a 4 roll here, guys. It is my favorite number, which is just a joke. I mean, it's for real, but I'm not solving for that or creating problems based on that. 16 divided by negative 4 is negative 4. So don't lose that negative sign in that final division step. It's very important because I'm solving for positive n. If I had a less complicated problem, make sure you get a good look at that. You can always stop the video, pause it and look at these things. But let's suppose I had let's just start with if I had negative 5n equals 20. Solve both sides, done. Isolate your variable, done. Solve by doing the opposite. I would divide by negative 5. Negative 5 divided by negative 5. N, 20 divided by negative 5. I did it again. Negative 4. All right, I'm going to get one that does not have 4 as an answer. That's funny. Okay, let's say with, let's do this. Get a little more involved here. What if I had negative 3n equals negative 27? They're solved. It's isolated. Got to do the last thing. So I'm dividing by negative 3. Negative 3. Negative 3 divided by negative 3 is positive n. Negative 27 divided by negative 3 is positive 9. A negative divided by negative is a positive. Let's just review this. Let me write this here again. You'll have your calculator, but this is super important. Multiplying and dividing are the same rules with negatives. But I'm going to write it. It's easier, I think, to see with division, with multiplication. A positive times a positive is a positive. Actually, a negative times a negative is also positive. A positive times a negative will give you a negative answer, and as you would expect, because we know that order does not really matter in multiplying, 6 times 5 is the same as 5 times 6, is all I mean. Negative times a positive is a negative. So when we're dealing with two numbers at a time, if the numbers are the same sign, this isn't multiplying and dividing. This is not addition. Addition and subtraction have a different rule. Positive times a positive is a positive. Negative times a negative is also positive. If the signs are different, though, the answer is negative. Memorize this, but again, your calculator will do this. Use the negative button, which is on the very bottom. It's in parentheses. It's a little minus sign in parentheses. That's what you would use for a negative. This is the exact same thing if these are division. The rules are the same for multiplication and division, okay? A positive divided by a positive is a positive. A negative divided by a negative is a positive. A positive divided by a negative is a negative. A negative divided by a positive is a negative. All right, so I hope that gives you a better understanding of algebra problems. Memorize these three rules. Get them locked in your brain, okay, so that you're used to doing them and you can just stay with it easily. Very systematic and orderly, like what we did. And remember, anything you do to one side, you have to do the other, because an equation is balanced. It's equal, so we have to keep it equal and just walk your way through it. Show each step, just like what I did. Don't try and jump steps, because then that's where you tend to lose things. Show each step, go piece by piece, and work your way down through it.